Let's talk a little bit more about solving equations involving fractions. So we're going to solve and check 1 over 3 times 2x minus 5 is equal to 3 over 4 multiplied by x minus 2. So I just kind of color-coded it here so we can see what parts are moving where. 1 over 3 times 2x minus 5 is the same as 2x minus 5 divided by 3. So I just kind of wrote that here. And then 3 over 4 times x minus 2 is the same as saying 3 times x minus 2 all over 4. On the left side, I have a denominator of 3. I need to eliminate this by multiplying the left side by a factor of 3. What I do to one side, I have to do to the other. So when I have divided by 3 and multiplied by 3, those cancel out. On the right side, I have a denominator of 4, and I need to eliminate that by multiplying it by a factor of 4. But what I do to one side, I also have to do to the other. So these become canceled on the right side. So I'm left with 4 times 2x minus 5 on the left side. And on the right side, I'm left with 3 from the original, 3 times 3, that's from the balancing, times x minus 2. So I go to distribute the left side, 4 into this bracket, I get 8x minus 20. And on the right side, 3 times 3 is 9. 9 times x minus 2 is 9x minus 18. So I have 8x minus 20 is equal to 9x minus 18. I need to go ahead and bring all of my constants and variable terms on either side. So I brought all of my variable terms over to the right side, and the signs changed, specifically with the negative 8x. And then my constants, and I changed the signs accordingly. So now I have negative 20 plus 18 is equal to 9x minus 8x, in which case is negative 2 is equal to x. When I perform the check, I'm going to be substituting the x value of negative 2 into the left and right hand side. So the left side I'm going to rewrite from the original equation, 1 over 3 times 2x minus 5. That would be equal to 1 times, in this case, 2 times negative 2 minus 5 all over 3. 2 times negative 2 is negative 4, minus 5 is negative 9 times 1. I'm left with negative 9 over 3, and then I go ahead and I can perform that math, and I'm left with negative 3. On the right-hand side, subbing in my value of x to be negative 2. Negative 2 minus 2 gives me negative 4, and this 3 over 4 is still tagging along. Now I multiply 3 by negative 4. I end up getting negative 12 over 4, which gives me negative 3. So both the left side and the right side balance out when x is equal to negative 2. Second example, we need to figure out or solve 1 over 2 times x plus 2 plus x is equal to 1 over 3 times 2x plus 1. So the new feature here is this another term of x. So I'm going to write it out, x plus 2 over 2, that's the same as 1/2 multiplied by, plus x is equal to 2x plus 1 all over 3. So on the left side here, I have a denominator of 2. How do I eliminate that? Well, I multiply it by 2. So I multiply this by 2, those cancel. But if I multiply this term by 2, I need to multiply every term by 2. So what we've done before is we multiply the left side and then we multiply the right side by that same number, but the third term that's been placed in here also needs to be multiplied by a factor of 2. So these cancel, this cancels, and what remains is the fact that 2 is now multiplied by x, and 2 now multiplies onto the right side. The other fraction that we see is on the right side. I have a denominator of 3. How do I eliminate that? I multiply it by 3. Now we know that we do to one side, we do to the other, which we've done, but it also affects that third term. So every term in the equation must be multiplied by a factor of 3 as well. So then these cancel, and I'm left with 3 being a factor or multiplying onto the left side of this term and the left side term of the x plus 2. So now, once those have canceled, I can simply rewrite it out. On the left side, I have 3 times x plus 2 plus, well, this is 2 times 3, right? Times x. So I have 6x. is equal to, well, these 3's canceled, so I'm now left with 2 times 2x plus 1, which I've written there. Now I go ahead and distribute my 3 into my brackets. It becomes 3x plus 6x is equal to, and I distribute the 2 into the brackets. 2 times 2x is 4x, and then it's plus 2. I need to move my variable terms on one side of the equation, my constants on the other. So now I have 3x plus 6x minus 4x, which gives me 5x. 2 minus 6 gives me negative 4. Now I continue onward. To isolate for my variable x, I divide both sides by 5, in which I'm left with negative 4 over 5 as the value for x. Going to solve this one. 3 over 2p minus 2 is equal to negative 7 over 8. So on the left side of the equation here, the only fraction I see is one of these terms has a denominator of 2. So I need to multiply this term by 2 in order for those to cancel. What I do to this term, I have to do to all terms in the equation in order for it to remain balanced. So now these cancel, but these other terms are still affected by a factor of 2. The other denominator I see is on the right side of the equation, and I have a denominator of 8. I need to eliminate this by multiplying by a factor of 8, and every term in the equation is also multiplied by a factor of 8. So now I'm left with 8 times 3p minus 2 times 2 times 8, which would be negative 32, is equal to negative 7 times 2, which in this case would be negative 14. 8 times 3p is 24p, and I bring this negative 32 over to become positive 32. That should be negative 14. Sorry. Can change things a little bit. That's okay. 24p is equal to negative 14 plus 32, which gives me a value of 18. Divide both sides by 24. P is equal to 18 over 24, and I reduce it so that I have it in lowest terms. In this case, is 3 over 4 is equal to p. And this is the last one. We have 2 plus 1 over 3 times 4x minus 5 is equal to 4 over 5 times 4x minus 1. So again, where are my denominators? I rewrote it so that this whole term is divided by 3. This is divided by 3, 4 over 5. I see a 3 as a denominator on the left side, so I need to multiply this term by 3, but also the other terms, all other terms. So now that this becomes canceled, this goes away, that goes away, I look for my other denominator, which is on the right side, and that's a value of 5. How do I eliminate this? I multiply it by 5, and I also multiply every other term in the equation by 5. So then these cancel, and I'm left with 3 times 5 times 2, which is 30, plus 4x minus 5 times 5 is equal to 3 times 4 times 4x plus 1, which I have written here. Then I go ahead and distribute 5 into the brackets. So then I have 5 times 4x, 5 times negative 5. So that would be 30 plus 20x minus 25 is equal to, 3 times 4 is 12, times 4x plus 1. I distribute the 12 into the brackets, and I end up getting 48x plus 12 is equal to 20x plus 5. So then I have to move my variable terms over and my constant terms. I bring my variable term over here, it becomes negative. I bring my constant term over, that also becomes negative. So now I have negative 7 is equal to 28x. Divide both sides by 28. I have negative 7 over 28 is equal to x, and I can reduce that further so that x is equal to negative 1 over 4. The big takeaway from this lesson when it comes to multiplying with fractions is that whatever you do to one term in order to cancel out a denominator, you have to do to all terms that are present in the equation.